Do you know the kind of electric circuit we use at home? Turning off the television set does not turn off the lights. Turning on the light in the bedroom does not switch on all the other lights in every room of the house. But what happens when the fuse gets busted? To answer these questions, let's discuss further about electric circuits. Electric circuits can be in series or in parallel. But how do we differentiate these two types of circuits? Just continue to watch this video lesson. Let's start with the basics of electric circuit. A closed loop through which current can flow is called an electric circuit. All electric circuits have at least three components: a voltage source, conducting wires, and loads. So I repeat, electric circuits have three components: a voltage source, conducting wires, and loads. Electric circuits may also have other parts as well, such as switches or switch. A voltage or a power source is a device that maintains a constant amount of voltage. Common voltage sources used at home are battery, generator, wall socket, and electric outlet. Next is a conductor or conducting wire to carry the current around the circuit. There is a corresponding safe amount of current that can pass through for every size, thickness, or cross-sectional area of conducting wire. So, it is important to consider the dimension of wire to be used when connecting a load or number of loads in a circuit. You may analyze or look for the sizes of wires in your home. And finally, the load that has resistance. It can be a bulb, a heating element, a motor, and others. A load is an electrical device that converts electrical energy to heat, like in the case of electric iron, and to light and heat, like in the case of a light bulb. Our appliances can also be considered as a load. Electrical switch, which is an additional element in an electric circuit, is a device that can control the entrance of current. When it is on, the circuit is closed. Then current can pass through. When it is off, the circuit is open and current cannot pass through. So you have an open switch and a closed switch. When the switch is on, the circuit is closed. Take note of that. While when the switch is off, the circuit is open. So we have here the basic electrical symbol. So here's the symbol for an open switch and for a closed switch. For a battery, for a cell, for a lamp or a bulb. Some uses it as a full circle, not a half. And you have the buzzer, the ammeter, the voltmeter, the resistor, and the fuse. So let us have this simple circuit. Let's try to answer. What do you think is the answer for number 1? What is this? Okay, very good. That is the battery. Then you have number 2, the switch. Number 3 is the load. And finally, number 4 is the connecting wire. So these are the components of an electric circuit. The battery is the voltage source or the power source. So generally, we have two types of circuit. The first one A circuit that consists of one loop is called a series circuit. So this is just a one loop circuit, plain and simple. So you have the battery, the connecting wires, the switch, and the resistance. So we have two resistance here. It can either be a bulb or any other load, where you have the voltage source, which is the battery as represented by the symbol. You have the total current. The symbol is capital letter I subscript T. You have the R1 and R2, or resistance 1 and resistance 2 are loads connected in series. If a series circuit is interrupted at any point in its single loop, no current can flow through the circuit and no loads in the circuit will work. In series circuit, if one light bulb burns out, the other light bulb will not work because it will not receive any current. A series circuit that consists of one loop is called a series circuit. Series circuits are commonly used in Christmas lights. That is why when one bulb gets busted, the rest of the bulbs will not function. The electrical switch is also connected in series with the light bulbs. Properties of series circuit. Number 1. The total resistance of a series circuit is the sum of all resistances in the circuit. Total resistance is always greater than the individual resistances in a series circuit. Number 2. The voltage source is equal to the sum of all voltage in each load in a circuit. Number 3. The current is constant across each load. Advantages of using series connection. Number 1. A series connection does not overheat easily. Number 2. In a series circuit, there is the only one path for the current to flow from the voltage source to the different loads. It would be easy to connect and disconnect new load. Number 3. Since series circuit is less likely to overheat, there is no need to use expensive or thick wires. So if you have Christmas lights in your home, try to look for the type of wire that is used for Christmas lights. They use thick wires which are not expensive. For the disadvantages for using series connection, number 1, if one of the light bulbs is damaged or removed in a series connection, all other light bulbs in the circuit will not light too. So that is one of the most difficult thing in using a series connection, because if one bulb gets busted, the rest will not function, and it is difficult to identify which bulb is busted or is not functioning. Number 2, the addition of more light bulbs in series circuit causes a decrease in the brightness of the bulbs. Since it is in series connection, the current flowing is the same or constant on all of the bulb or load. If you continuously add bulb, then the brightness of the bulbs will decrease. Number 3, the loads in a series circuit are difficult to control individually. When the switch is off, all loads in the circuit will not function anymore. Number 4, I have already mentioned this one. It is difficult to identify the damaged bulb in the circuit. For the second type of electric circuit, we have the parallel circuit. A circuit that has two or more loops is called a parallel circuit. So as you can see, it is a different diagram as compared to the series circuit, where V stands for the voltage source. In this diagram, our power or voltage source is the battery. You have the I1, the current at resistance 1, I2, the current at resistance 2. You have the IT or the total current. R1 and R2 are loads connected in parallel. If one loop is interrupted, the current can still flow through the other loop. If one light bulb burns out, the other light bulb will still work because current can still flow through it. So at this instant, you can already identify what's the difference between a series and a parallel circuit. In a series circuit, once that one bulb is interrupted, the rest of the bulb will not function. While for the parallel circuit, if one of the loop is interrupted, the current will still flow through the other loop. If one bulb gets busted, the other bulb will still function. A common example of parallel circuit is the connection of electrical wirings at home. So our electrical wirings in our home applies or uses parallel connections. Properties of parallel circuit. Number 1. The reciprocal of the total resistance in a parallel circuit is the sum of the reciprocal of all resistances in the circuit. Number 2. There is only one voltage which is equal to a voltage source. Number 3. The total current is equal to the sum of all currents in each load in a parallel circuit. Advantages of using parallel connection. Number 1. All loads in parallel connection are directly connected to the voltage source. 2. In a parallel circuit, even if one of the light bulbs is damaged, all other light bulbs will still function since the flow of current is not entirely interrupted. Number 3. Individual load in a parallel circuit is easy to control. And number 4. All light bulbs and appliances at home are connected in parallel. Switching off some appliances does not affect other appliances. So if you want to turn on or turn off the lights on one room, it has no effect or it does not affect other lights on the other rooms. While for the disadvantages of using parallel connection, number 1, overloading may happen if appliances are simultaneously used at home. Number 2, a parallel connection is difficult to install, maintain, and repair since large volume of conducting wires is needed. Number 3, it requires the use of several conducting wires of varying sizes. At this point, let's check your understanding. Question number 1. What happens to the brightness of the bulbs connected in a series circuit when more and more bulbs are added to the circuit? Letter A, increases. B, decreases. C, remains the same. Letter D, cannot be predicted. Okay, if your answer is letter B, decreases, then your answer is correct. So the brightness of the bulb decreases if you add more and more bulbs to the circuit. Number 2. In a simple circuit, the blank supplies the electrical energy. A. 1.5 volts battery. Letter B. 10 watts bulb. C. Connecting copper wire. Letter D. Charges. So what supplies the electrical energy in a circuit? The answer is letter A. 1.5 volts battery, that is the voltage source or the power source. Number 3. The path that the electricity flows from the battery to the light bulb and back to the battery is called the blank. A. Circuit, B. Wire, C. Component, D. Switch. For number 3, the answer is letter A. Circuit. Number 4. A device for opening or closing the flow in a circuit is blank. A. Bulb, B. Wire, C. Switch, D. Battery. For number 4, the answer is letter C. Switch. This is a device for opening or closing the flow of electricity in a circuit. Number 5. True or false? So let's analyze this picture on the screen. An electric circuit is a closed loop or pathway that allows electric charges to flow. Okay, the answer for this statement is true, because an electric circuit is a closed loop or pathway that allows electric charges to flow. So as you can see, it is a closed loop that allows the electric charges to flow. So we have the voltage source or the power source, you have the load, and you have the connecting wires. In some electric circuits, you have an additional element, and that is the switch. Next, true or false? You have here a simple circuit, a series circuit, and a parallel circuit. A parallel connection is a type of electric circuit in which there is a single current pathway. So this picture will give you a hint or an idea if the statement is true or false. Again, the statement is a parallel connection is a type of electrical circuit in which there is a single current pathway. For this statement, the answer is false, because the connection with a single current pathway is a series circuit. So that would be all for this episode about electric circuit. See you again next time for our next video lesson.